Hi, my name is Parag Pal and welcome to my next lecture of Module 2 and Module 3. In this particular lecture, I am talking about the total analysis of building through the ETAB. What are the steps we are concerned related to ETAB that we are going to discuss today? Okay, so first one, the step one is a preliminary data. What is the preliminary data you required? Okay, the preliminary data you required is only the grid pattern, the plan structure, the column sizes, okay, the column positions, the orientations of the column, the basic requirement, basic dimensions of the column and beams, okay, the height of the story. We used to call it as a bay by bay system, okay, and the rest data like step bearing capacity and all, okay, of soil. Second thing is you need to prepare a new model, okay, and formation of grid. You have to prepare a new model, okay. You can prepare itself in ETAB or you can import the file from AutoCAD, okay, to ETAB and prepare your model. You can import the model from AutoCAD to ETAB and post process in the upward Y direction or Z direction. Okay. What is the meaning of post processing? Post processing means increase the 2D model in an upward direction in a number of multiple story buildings. Okay. Formation of grid means what? Formation of grid is nothing but draw the layout in ETAB. Okay, because whenever we draw the layout on a site, we will get the cross points. That cross point means what? The column foundations, right? Now, the stage number three is defining material properties and defining section properties. Definitely, defining material properties means what? Look, yesterday or day before yesterday, I talk about the different kind of the material. If your building is very high story building, you cannot use M20 grade of concrete. You need to improve the gradations of your, you need to improve the characteristic strength of your concrete. Then and only then it is possible to withstand under the different kind of the loading conditions. If you are not able to provide that kind of strength, then you need to improvise your sizes of the column. Okay, look, the strength is inversely proportional to the dimensions. If your strength of a material is very less, so you need to increase the dimension. If your strength of a material is very high, then definitely your dimension will reduce. Understand? Because the 20,000 Newton per mm square loading, okay, is very less for a multi-story building. If you are looking for a multi-story building, I prefer you go for M30, M45 grade of concrete, okay, because you need very high strength. After that, defining section properties. Look, as you can go for a analysis and design, you need to require the dimensions for the building. You require the dimensions for the steel structure buildings. If you are going to provide the bolted connection, welded connection, for that the tension member you need to provide. So equal angle section, channel section, pipe section, circular section, different kind of sections you need to provide. So these are the section properties you need to understand properly. After that, analysis, assigning frame sections and support. Yes, after that, when we construct everything, we need to provide the support to the column, support to the building. Okay, like you want to make it as a sway, you want to make it as a non-sway. Okay, basically we make it as a non-sway, right? But we provide the only support at the bottom because in fixed support we got three reactions. First one is at uppermost directions, one is a thrust one, and another one is a movement, right? So these three directions we will get in our um, fixed support. Now after that, stage number five is assigning the load. We need to assign the different kind of load conditions according to IS 875 and our manual calculations. After that, section number six is the analysis and comparison of base reactions. In this is one of the important step what we have. In this stage, we need to analyze and compare the base reactions, the reactions what we got. Okay, the load combinate due to the load combinations, what are the different kind of the loading we are loading results we are getting that we need to analyze. Then step number seven is defining load combinations. As I told you earlier in my last model number one lecture, that the dead load plus lie load, dead load plus wind load, dead load plus wind load plus lie load. Okay, these three different kind of the combinations for collapse and serviceability that we need to check. After that, designing the structure. When you go through all these things, when you got lots of checks, corrections and error, trial and error, after that we will go for the design of structure. Okay, so let's see the stage number one. Now here you can see the column data. This kind of plan you required. Okay, this is a very important data. If without this you cannot go. If you don't have the distance between the column to column, okay, column to column distance you don't have, what does it means? You don't have bay by bay distance. Bay by bay distance means what? Room by room distance. You don't have the room by room distances. You require room by room distance. Understand? After that, you need all column sizes, all column to center distance you required very well at the start of the project. Second thing is you require the elevation height also. Only the top level, only the top portion height if you have, it doesn't mean that you have all the data. You require the post-processing data also. So post-processing means what? You require the height data. Okay, so 1.5 for foundation and rest we provide for a story height, right? Like this. After that, here the material types you need to provide, like concrete and rebar. Rebar is like reinforced. Specification like Indian M20 or Indian high yield strength deform grade 415 bar. Okay, so if you are using concrete for M20 and rebar for HYSD 415. So your column is having 300 by 500, 400 by 400, 400 by 500. Okay, and beam is having 300 by 600, 300 by 500, 300 by 400. You can see the one common thing is that the thickness, okay, like the width, okay, is constant at all, and the depth is varying. Why? Because the distance, as the distance increases, okay, and as the height of story increases, your depth will increases. Okay, and we are considering a slab thickness of 125. All these data in mm. After that, these important things you need to know, like grade of concrete, grade of steel, live load on roof, live load on floor, roof finish, floor finish, brick wall on intern beams, density of concrete, brick density, wall including. Okay, this all these data are very important during calculation of loading conditions. After that, the stage number two. You need to create a new model and grid formation. How we can do this? So you can see the ETAP view. This is ETAP view. Here you can see you can select the blank one or you can select the 3D plane also and you can modify it. But here I am what I'm doing. Here I'm doing the grid only pattern. Okay. After that, I can provide all the data. Like you can see if I go to the this map plan. Okay. If I make this plan on this 000 coordinate, so this become my x direction, right? This C2 to C2, this is my x direction, this is my y direction, okay? And if I come in this direction, it will be my z direction, right? So same thing I have to do over here. I need to provide the data like how much in x direction, how much in y direction, and how much in z direction. Number of grid lines I have to provide. Okay, so grid line means what? I can show you once again. So this is your first grid line. Second, third, fourth, fifth, sixth. So there are the six grid line on the x direction that you need to provide. Okay. Same on y direction, same on z directions. Understand? Now grid spacing. The spacing between the two grid, like 4 meter, 3 meter, you can see over there in the both that plan, in that available plan is 4 meter, 5 meter. Whatever we have, you need to provide. And then first grid line location, and definitely as I told you, you need to provide a grid pattern on 0 comma 0 comma 0 coordinate. That means on a 0 ordinance. So xyz is on the 0 comma 0 comma 0, right? And this we provide in Cartesian system. Understand, it should be always a global because it consists xyz direction. Now the defining grid pattern, so you can see as we provided the grid id, the spacing, the visibility, and the spacing we can provide over here. Okay, like first grid line 5 spacing, second grid line 5 meter spacing, and third is having no 0. Okay, z grid line, what kind of spacing we have, that we provided. So x line, what we are providing over here on a x grid line, the grids, their spacing, Okay, so A, how much spacing he has. B, how much spacing the grid line is having. C, D, E, like F, that kind of data we provide over here. Similarly, on Y direction only, and Z direction you can see there is nothing like that. Okay, only in 3D pattern you need to know, you know. After that, stage 2, the over. So when you finalize the model, you can see the structure like this. Understand? So you can see this is the X direction. Okay, sorry, as Y direction, X direction, and Z direction on over direction. Now the defining stages. So you can see the define material and define section properties. I'm just giving the overlook for the ETAP software because during the implementation we will get to know each things very properly. So now the define material properties and define section properties. Here you can see we need to provide the if as I told you if I have to modify it you need to click on that M20 grade of concrete, okay, and you can click on modify, or you can add the different kind of material like M30 M40. If you want to add you can go over here and add. If you want to add high steel L bar 500 500D you can go over here, click on add, you will get the data. Now after that you can see this kind of the quick definitions you have to create. Now properties also, if you want to create a section property like beam size you have to create, you can go on add new property, click over here, you can need to create a copy, create a property, it will definitely show over here. Okay, so now when you click on this line you get to know this particular kind of structures like rectangular, circular. Here also options are given like steel, every kind of structures, material, properties over given over here. You just need to select and provide a dimension. As you selected the column 1, you need to provide the depth and the width. Okay, and concrete reinforcement also you need to provide and provide the name for a column. After that, as you provided the all data, also you need to provide the design type. You need to provide whether it is a beam or column. Okay, that also you have to provide. How reinforcement configuration you have to provide, that also you need to provide it over here. If it is circular, then the reinforced confinement bar is a spiral. If it is rectangle, then it is tiles. Okay, the lateral tiles what we are talking about. The clear cover you need to provide the number of longitudinal bar along the three direction faces and two directional faces, bar sizes, okay, then lateral ties dimension and their spacing, okay, and the check. Yes, this is one of the important one. That's the reinforcement to be checked or reinforcement to be designed. So always it is reinforcement to be designed because if we check, it will always try to interpolate, and due to this, our design may get fail. Then when you finalize a section, okay, like this, you can get the section over here. Okay, I will teach you each and every single step so you can get to know what exactly we have to learn. After that, similar for a beam section, okay, you can see I have provided a design type of a beam. Okay, so all this data we provided as per our that plan. So for this, the plan is very important. Then the last step is assigning of frame. After that, you need to select the frames, like you need to select the parallel X direction, parallel Z directions beam, and assign the beam property, parallel Y direction sections, okay, and provide a column access. Now assigning the load. We have different kind of load pattern like dead load, dead slab, dead wall, dead retaining roof load, floor finish. Okay, lie load we have. This we need to provide. Okay, so if you have external wall load intensity, how you can provide? 0.23 is the wall thickness, 1 is a unit quantity, 3 minus 0.45, okay, is total depth, okay, into 20 is the density. So what you got? You got 11.73 kilonewton per meter. Similar for the internal also, okay, and parapet wall also you have. But look, one thing is very important, okay, what is that? 0.45 means what? Here I am reducing the size of the beam. Here I am also reducing size of the beam. Here only 1.5 is the height of the parapet wall, so I am taking. So it is width into length, okay, into height, into density, right? So we got this kind of loading condition. If you don't want to use this kind of loading conditions, okay, you can go to the direct as 875 part number 1 for a dead load and live load. Now second one is assigning the area like one-way distribution, two-way distribution. Okay, so that is also important one. After that, you can see this kind of diagrammatical representation where intensity of slab load is very important. How you can calculate the intensity of the slab load? Intensity of the slab load is calculated by the thickness multiplied by the density of slab. So you got 3.125 kilonewton per meter. Okay, so the ordinance of triangle is what 2. How we can calculate the thickness? You remember one thing. Whenever it is a two-way slab, the distribution is in a two different diagrams. One is a rectangular and another is a trapezoidal, right? So if you have to calculate the ordinance of the rectangular triangular road, how you can calculate the overall distance is 4, make it half, become 2 2. So multiply this intensity with this half distance 2. Okay, you will get the data. Okay, you got the ordinance 6.25. It means at this point, at 2 meter, this means the top distribution point is 6.25. Okay, and this trapezoidal load, how you can calculate? Just multiply, okay, this 2 and 2. Okay, it is 5, right? So 5. So also you need to calculate the half distances. How much distance till this rectangular section you need to calculate and multiply that particular distance with the intensity of slab. Usually you need to calculate the load from this point to this point. Okay, because this trapezoidal consists of two triangle and one rectangle. Okay, understand? So it become the 2 into 3.125, it becomes 6.25. Okay, so at this point, your loading condition is what? 6.25. Understand? So at 0 point, so let's look for a rectangular load first. At 0 point, your load is 0. At 2 meter distance, your load becomes 6.25. Again, at 4 meter distance, load becomes 0. So 2, 0, 2, 4. Understand? Now here, similar for this section, 0, 2, 4, 6. Okay. So at 0 distance, okay, your load is 0. At 2 meter distance, your load becomes 6.25. At 3 meter distance, your load becomes 6.25, and at 0 meter distance, means at 5 meter distance, your load becomes 0. Understand? So now you can see this kind of the self-weight, lie load, floor finish, roof treatment, and lie load we need to apply. So you can see how we can do these things. So you have self-weight of slab. Okay. So at 0 meter distance, do you know like 0 meter distance it is 0. 2 meter distance it is 6.25. So how you get 2 multiply with the that intensity ordinance. Okay, so you got this 6.25. At 3 meter distance also we will get same value. At 5 meter distance it become 0. Now if you have to provide the lie load, the lie load we are providing how much? We are providing lie load as a 3 kilonewton. So 2 multiplied by 3 becomes 6. 2 multiplied by 3 becomes 6. Okay. Likewise, we will provide the all the load conditions. Okay. Now you can see this kind of the loading conditions when we provide on a beam and column, you can see like this. Okay. Now after that, how you can analyze and compare the beam reactions. It is one of the important one. Okay. So column, with respect to column, we got this kind of load. With beam, we got this kind of load. Okay, now this is a the sap reactions. I will discuss this further because now if I explain it, you're not in a position to understand. Okay, now we will compare the all loading conditions from our side and from the software side. Now the medium soil type. Look, we need to look for the sag by period connections. Okay, it is a earthquake loading condition where we are define the response spectrum function. As the sag increases till certain period, okay, as the zero period increases, period increases, your sag also decreases. Okay, like you can see, sag means what? The more deflections. Okay, sag means what? At zero period, your sag is very high, but as the period increases, your sag is decreases. It means what? The durability of the soil is decreases. Now, if you need to define the response spectrum load cases, the scale factor is defined by the formula Z by 2 I by R into G. is equals to 0.35316. So no need to understand this formula, only the shape factor you need to understand because it is a common one, 0.35316. Okay, so you can see this kind of graphical representation we always got whenever we go for the earthquake analysis, and we will see during our overall process. Okay, these things not in a position right now. These are the different load combinations we will use for our overall design and analysis of the building. Okay, we will graphically review the deflection, shear, bending moment, axial forces, and concrete frame design. Okay, like this. Understand? So these are our last stages. Thank you so much. Here I am completing my the theoretical portion from next video, which is I'm going to provide you on a next day. Okay, it is always about related to the basic of the ETAF. Okay, and we will start from the practical now. Thank you so much. Have a nice day. Bye bye.